Olivia over at Prepaze, and today we'll be going over episode 7 in our function series. Now, last episode we talked about writing equations of lines in what we call slope-intercept form. Slope being that constant rate of change we talked about in episode 5, and b being our y-intercept, or when our graph intersects with the vertical y-axis. In this case, we'll be going over point-slope form, which uses that same slope constant rate of change value, m, and you guessed it, a point. So the point is a known point on our line, which we can calculate either it's going to be given to us or we can see it on the graph. We know it's a point that exists, that the horizontal movement and the vertical movement will lie on a point on the line. So if we plug those values into the equation, we should be able to get the same expression. In our last video, we talked about the point 3, 9 being on our expression. And just so I can verbally walk you through it, if I input the value of 3 into y equals 2x plus 3, 2 times 3 is 6, plus another 3 is 9. So input of 3 creates an output of 9. So 9 is our rate of, 9 is a point on our graph. So if I'm going to follow the category, slope being 2, like we discovered in the last video, if I plug that in, my expression will be y minus y1, the point, which is 9, is equal to 2, which is our slope, multiplied by x minus our given x value, which was 3. So following the equation of the same line, but in point-slope form, it's going to be y minus 9 is equal to 2 multiplied by x minus 3. Fun fact, if you distribute the values and isolate y in point-slope form, you will get still the slope-intercept form. So let's just do it for fun while we're here. So distributing 2 into the x minus 3, we'll get y minus 9 is equal to 2x minus 6. If we add 9 to both sides to isolate x, y minus 9 plus 9 is y plus 0, or y. 2x minus 6 plus 9 is a positive 3. 2x plus 3, and we get our slope-intercept form. So it does work. Sometimes point-slope form is a little bit easier to find, and it saves you from having to do that intercept calculation. Now, maybe you don't believe me that two lines are equations to describe the same line, but check it out over here on my graph really quickly. Previously, I had the red line up for our slope-intercept form. Now, I've plugged in that point-slope form with the blue line, and they happen to line right on top of each other, so we can't actually see any red anymore. So these are two different ways that we can express the same function as equations. And depending on your situation, it will call for one versus the other. But for any of these cases, you'll always need at least a minimum of 2 points to figure out your slope value, and then 1 point to either find your y-intercept, or if you prefer point-slope, using it for your point-slope form. So you can find the equation of a line with 2 points. You only need 2 points, then you can find the equation of your line. All right, thank you so much for joining me for this series, and I will see you guys later.